Hi students, in this video I'll be going through the 2013 O-Level Paper 2 question 10. Alright, so this is a question regarding circles. Okay, so the question goes, a circle has the equation x squared plus y squared plus 6x minus 4y minus 12 equals to 0. Okay, so over here we are given the equation of the circle in the general form. Okay, so for part 1 we are asked to find the coordinates of the center and the radius of the circle. Okay, so if we are given in the general form, I prefer to use the 2G2F method, right? So the general form of the equation of a circle goes like this: x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Okay, and then the center can be found by minus g minus f, and then the radius will be square root of g squared plus f squared minus c, right? Okay, so in this case, we can identify that 2g, by comparison, 2g will be equals to 6. Okay, so g will be equals to 3, and then 2f is equals to minus 4, then f will be minus 2. Okay, so remember the center is minus g minus f. Okay, so minus g will be minus 3. Minus f, be careful, minus 2, it becomes 2. Okay, so the coordinates of the center will be minus 3, 2. Okay, so you can see that using this 2G2F method, you can get the coordinates of the center quite easily. Okay, so the radius can be found quite easily as well. Okay, so square root of g squared. So in this case, g is 3, f is negative 2. And then be careful now, c is over here. Must include the negative sign. So c is minus 12. So minus c will be minus 12. Okay, so that will give us the square root of 3 square 9 plus negative 2 square 13 minus become plus 12, so 25. So the radius will be 5 units, right? Okay, so this 2G2F method can allow you to find the radius and the center quite easily. But of course, you can also complete the square and then convert the equation of a circle to the standard form and then use that to find the center and the radius of the circle. Okay, let's move on to part 2 of the question. Okay, so part 2, we are asked to show that the equation of the tangent to the circle at point P, negative 7, negative 1, is 3y plus 4x plus 31 equals to 0. Okay, so for questions such as this, I always recommend that you draw out the circle. Okay, so to draw out the circle, we always start by drawing the center first. Right, so in this case, the center is minus 3, 2. So you can just plug a random point on your paper. Okay, so that will represent the center of the circle. Okay, so where would point P be? Okay, you ask yourself, where would point P be? P is negative 7, negative 1. Okay, so to locate the position of point P, okay, you will take a look at the x coordinate of C. Okay, so x coordinate of C is negative 3. X coordinate of P is negative 7. So point P is going to be to the left of C, right? Okay, then how about the y coordinate? So the y coordinate of C is 2, and then the y coordinate of P is negative 1. So P will be below point C. Okay, so the position for P will be roughly here to the left and then below. Right, so it's always very important for you to consider drawing out a diagram so that you can visualize the question better and it will enable you to solve the question more successfully now. Okay, so although you spend maybe 2 minutes to get the diagram out, but I think it's a worthwhile investment in time because it will enable you to find the solutions or work out or plan your working more easily, right? Okay, so how do we find the equation of this tangent at P? Okay, so a tangent is a line that just touches the point P and cuts the circle, or rather touch the circle only at one point. So it doesn't cut the circle at any other point. Okay. Okay, so to find the equation of a line, we need to know two things. Okay, firstly, we need to know the coordinates of one of the point that it passes through. So over here, we already know the coordinates of point P. Alright, so the other thing we need to know is the gradient of this tangent that touches point P. So the gradient of the tangent. Okay, let's call it TAN. Okay, so in order to find the gradient of the tangent, we need to use one circle property. Okay, if we were to join the points P and C with a straight line, so over here, join with a straight line. Okay, what can we say about the line CP and the tangent? Yes, they'll be perpendicular to one another because over here, we are using the property tangent perpendicular to radius, all right? So in other words, we can make use of the line CP to help us to find the gradient of the tangent at P. Okay, because if two lines are perpendicular, the product of their gradients will give you -1. Okay, so now we should go ahead and find the gradient of CP, and then after that we can use it to find the gradient of the tangent, and then after that we can find the equation of the tangent at P, right? Okay, so let's get down to work. Okay, so gradient of CP. Okay, so y2 minus y1. So I'll use P minus C, so -1 minus 2 over -7 minus -3. Okay, so over here we will get 3/4. Okay, so having found the gradient of CP, we can find the gradient of the tangent, because gradient of tangent times 3/4 will be -1, right? So the gradient of the tangent will be -4/3. Okay, so once we find this, we can find the equation of the tangent. Okay, so equation of tangent at P. Okay, so remember, equation of a straight line, we are going to use this y minus y1 equals to mx minus x1 to find, right? So the x1 and y1 will be the x and y coordinates of point P. Okay, it must be a point that the line passes through, all right? So y minus y1, okay, equals to m x minus x1, all right? So y plus 1 minus 4/3x, okay, -4/3, okay, times plus 7, okay, minus become plus, so -28/3. Okay, so just one more step and we'll get our answer. So just bring the 1 over. Okay, so minus another 3/3, you will get 31/3. Okay, but we're not done yet because they want us to put it in this form, right? 3y plus 4x plus 31 equals to 0. Okay, so we're going to multiply by 3 throughout. Okay, and then after that, bring everything to the left side. Okay, so shown, all right? Okay, so not too difficult. Okay, in fact, this is a rather standard question that is always asked. Circle question now, all right? Okay, let's take a look at the next part of the question. Right, the point Q, which lies on the circle, is the same distance from the y-axis as point P. Okay, so point Q, I've drawn it over here. Okay, but why did I draw it over here? Okay, because the question told us that it's the same distance from the y-axis as point P. Okay, what do they mean? Okay, when they mean distance, they mean the perpendicular distance. All right. So if I draw a line, perpendicular line, from Q to the y-axis, this distance will be equal to this distance. Okay, so these two distance will be equal. Okay, so having said this, what can we say about the, let's say, x coordinate of point Q? Okay, since they are the same horizontal distance away from the y-axis, okay, do you agree with me that their x coordinate will be the same? Okay, so it should be the same, right? Okay, so do think about this. Okay, so this is something that you need to pick up from the question now, right? Okay, next thing is I'm going to join this P and Q with a vertical line. Okay, so since they are same distance away from the y-axis, okay, so vertical line disappears. Okay, so let me redraw this. Okay, Right. Since they are the same vertical distance away from, they are the same horizontal distance away from the y-axis, right? So this, if I draw a straight line from Q to P, it's going to be a vertical line straight down, all right? Okay, so now I'm going to draw a perpendicular line from C to this line that I've drawn, this vertical line. Okay, let's say I write a thing here, M, okay? So let's say I write M here. Okay, what can you say about QM and PM? Okay, so if you recall, there's this property that you learned in E-math called perpendicular from center, okay, will bisect the chord. So this PQ is actually a chord, okay? So it will actually bisect it, meaning this length is going to be equal to this length, right? Okay, so let me ask you, what is the length of PM? Okay, what is the length of PM? Okay, to find the length of PM, since QM and P is a vertical line, right? We just need to look at the y coordinates. Okay, because this line CM will be considered as level 2. Okay, level 2. Follow the y coordinate, and then this dotted line below over here will be considered as level -1. So from -1 up to 2 is total of 3 units, correct? Okay, so since this chord has been bisected into 2 equal parts, okay, by this line CM, so do you agree with me that this is also going to be 3 units? Okay, so if this is going to be 3 units, then I know the y coordinate of Q already. So the y coordinate of Q is actually 2 plus 3, right? Okay, 2, because over here is level 2, okay, plus 3 units, so become 5. So from here, I can know the y coordinate of Q, and then with the y coordinate, actually I know both coordinates already, okay? And that will actually allow me to find the, using a similar method to part 2, to find the equation of the tangent at Q, okay? So basically what we need to do now is we need to find the gradient of CQ. Once we know the gradient of CQ, we know the gradient of the tangent at Q. Once we know the gradient of tangent at Q, we can find the equation of the tangent at Q. Okay, so let's go ahead and do that now. So I'm going to write from the diagram. Okay, so I'm just going to tell them how we found coordinates of Q. Okay, Q equals to -7, 5. Right? So gradient of CQ. Okay, so y2 minus y1, so 5 minus 2 over -7 minus 3. Okay, so that will give us -3/4. Okay, so okay, this one, let me call it a gradient of tangent at Q, okay, adding a Q. So gradient of tangent at Q, okay, times -3/4 will give me -1. Okay, so same thing. This tangent is perpendicular to CQ. Okay, so the gradient of tangent at Q will be 4/3. Okay, and then therefore we can find the equation already. So equation of tangent at Q. Okay, so y minus y1, so we need to use the coordinates of Q, equals to m x minus 7. Right? Okay, so you get y minus 5 equals to 4/3x. 4/3 times plus 7, you get 28/3. Okay, just going to bring the 5 over. Okay, bring the 5 over, you will get plus 15/3, so 43/3. Okay, so from here, I think we're going to put in a similar form as part 2. Okay, so it times 3 throughout, so you get 3y equals to 4x plus 43. Okay, so 3y minus 4x minus 43 equals to 0. Okay, so this will be the answer, right? Okay, but technically you can leave your answer in this form or this form now. Okay, it's equally fine. Okay, the next part, the tangents to the circle at P and Q intersect at the point R. So find the coordinates of R. So as you can see from this diagram, that's why it's important to draw a diagram. these two tangents will intersect at this point R. Okay, so whenever you see the word intersection point, okay, or something similar, okay, you should think of solving simultaneous equation, and that will allow us to find the coordinates of point R. Okay, so that's what we are going to do here. Okay, so we're going to let the equation of the tangent at Q, okay, at P and Q be equations 1 and 2, and then after that we solve them simultaneously. Okay, so let's do it now. So equation of the tangent at point P will be this one, right? So let's call this equation 1. Okay, equation of the tangent at point Q is this. So let's call it equation 2. Okay, so you see both have the 4x, so actually we can add up the two equations and then we'll be able to get rid of the x already. So 1 plus 2. Okay, so if you add the left side 1 plus 2, you get 6y. Okay, then 31 plus negative 4h, you get minus 12 equals 0. So 6y equals to 12. So y will be equals to 2. Alright. So substitute y equals to 2 into equation 1. Okay. So what we'll get is 3 times 2 plus 4x plus 31 equals to 0. Okay, so continue over here. So 4x equals to, okay, so 6 plus 31 is 37. So you bring over, you get negative 37. So x will be negative 37 over 4, right? So therefore, r will be negative 37 over 4. And then y will be 2. Right, so this is how you solve a question like this. So this is a paper 2 question, that's why it's a slightly longer question, total of 12 marks. Okay, but you can see that part 1 is easy. Part 2 and 3, I would say rather standard to find the equation of tangents. Okay, just that for part 3, you need to figure out the coordinates of Q first now. Okay, so that requires some thinking. But then again, I strongly encourage you draw a diagram. So bring your compass to the exam, draw a nice circle, will help you to visualize the question better, right?